Welcome back, everybody, for another deep dive. This time, we're going to be tackling something that I know a lot of you have probably run into at some point. Those pesky NaN values you find when you're working with data in Python.
Yeah, you're going along coding and analyzing your data, and suddenly, wham, -NaN.
Exactly. Like, what do you even deal with that? Today, our guide is going to be this excerpt from Python check if value is NaN. A complete overview. We're going to break it down, and by the end of this, you'll be ready to handle NaNs like a pro.
Absolutely. We'll be covering what they are, why they matter, and how to deal with them effectively so you don't have to stress when you see one pop up.
Okay, so first things first. What is this NaN thing anyway?
Well, NaN stands for not a number. It's basically a special value that pops up when Python's trying to do some math and just can't come up with an actual number as the answer.
Okay, so it's like the calculator just saying error.
Pretty much. You know, like if you try to divide by 0, mathematically that's just like undefined. So in Python, you get a NaN.
Huh, okay. So it's not just division by 0 though, right?
Right. You can get NaNs from missing values in your data sets, corrupted entries in a spreadsheet, even taking the square root of a negative number.
So it's Python's way of basically saying, I don't know what to do with this.
Yeah, basically. But why should we even care, right?
Yeah. Are they really that big of a deal?
Oh, they can be a huge deal. Imagine training a machine learning model, right? And your data set have a bunch of NaNs. The model might just learn to basically just ignore those data points, and then all your results are skewed.
Oh, wow. I hadn't even thought about that. So they're not just like annoying. They could actually mess up your whole analysis.
Exactly. That's why it's important to know how to find them and how to deal with them properly.
Okay, so let's talk about actually finding these NaNs then. How do we even spot them hiding in our data?
Luckily, Python gives us some great tools for this. The source we're looking at talks about 3 main ones. There's numpy.isnan, math.isnan, and pandas.isnan.
Okay, 3 whole tools. So how do we know which one to use when? Like if I'm working with a pandas data frame, but also need to check a couple individual values.
Well, each tool has its strength. If you're working with numerical arrays, you know, the kind you'd find in a big data set, -numpy.isnan is the way to go.
So that's for like heavy-duty data work, lots of numbers. Yep. What about math.isnan?
Math.isnan is more lightweight. You'd use that if you just need to quickly check a single value, like making sure someone typed a real number into a form, you know.
Oh, so like for quick checks and stuff like that.
Yeah, exactly. And then there's pandas.isna.
Right. And what's so special about that one?
So pandas is great for data analysis in Python, like really great. And DataFrames are like souped up spreadsheets within pandas. Pandas.is is specifically for finding NaNs in DataFrames.
So if I'm doing any serious data stuff in pandas, that's my go-to.
You got it. It's the perfect tool for working with those powerful pandas DataFrames.
All right, so now we know how to spot them. What about getting rid of them? I mean, we talked about, like, removing rows, but wouldn't that mean losing information? Sometimes those missing values are, like, important clues.
Right. Sometimes, instead of deleting, you might want to replace the NaNs with something else.
Okay, so what could we use to replace them?
It really depends. Like, you could use the average of the other values in that column. You know, it's called mean imputation. Or the median, which is good if you have outliers that might skew the average. And sometimes you just want to use a constant value, like 0.
So, like, no single right answer. Just got to figure out what works best in each case.
You got it. And that's actually what we're going to be getting into more in the next part of our deep dive. We'll look at those different replacement strategies and when to use each one.
Awesome. I'm already starting to feel a lot less intimidated by NaNs.
So we've been talking about replacing NaNs, right? But sometimes you actually don't want to change the data. Like sometimes those missing values can actually tell you something important.
Yeah, it's kind of like when a detective finds a footprint at a crime scene, you know?
Yeah.
You don't just want to erase it. You want to figure out what it means.
Exactly. Like, say you're working for a streaming service, right? And you see a bunch of NaNs in the watch time data for a new show. Well, instead of just like filling those in with some made-up number, you'd probably want to know why people aren't watching, right?
Yeah, for sure. Like, is the show just not good? Or maybe there's some kind of technical glitch that's making people turn it off.
Right. Or imagine you're a medical researcher looking at patient data. You see lots of NaNs in a certain field. Maybe it means those patients just couldn't give you that information, you know?
Oh, interesting. So, like, maybe they don't have access to certain healthcare or something.
Exactly. And if you just fill those in with fake data, you might miss those bigger issues.
Wow, that's a great point. Okay, so everything we've talked about so far has been about numbers,
Yeah.
right? But what about missing information in text T? How do we deal with that?
That's a great question. Text data is a whole different beast. I mean, think about social media posts or product reviews or even medical records. They're full of unstructured text that can be super messy.
Yeah, I can imagine. Typos, slang, incomplete sentences. Must be hard to analyze that kind of stuff. There's no like NaN for text, right?
Nope.
Very
No
well.
universal, not a word value. But don't worry, Python has got us covered. One of the most powerful tools for this is regular expressions.
Regex. Ooh, that sounds kind of scary. Do we really have to learn that?
I know. It has a bit of a learning curve, but trust me, it's so worth it. Regex lets you define these patterns to search for and manipulate text. You can use it to find specific words, phrases, or even like combinations of characters that might indicate a problem.
Okay, I'm kind of starting to see how that could be helpful. Can you give me an example?
Sure. Imagine you're looking at customer reviews for a product. You could use Regex to find all the reviews that say things like broken or defective or doesn't work.
So you could like automatically flag all the negative reviews?
Exactly. And it's also really useful for data cleaning. You can use regex to find and remove weird characters or extra spaces or even like fix formatting issues.
So it's like the ultimate text data tool.
Pretty much. But what if you're not quite ready to dive into regex just yet? There are simpler things you can do too. Like Python has some built-in string methods that are super helpful.
Oh, cool. Like what?
Well, for example, there's this thing called the strip method, and it removes extra spaces at the beginning and end of a string.
Oh, yeah. I hate those extra spaces. They get everywhere.
I know, right? And if you have text with like inconsistent capitalization, you can use the lower or upper methods to make everything lowercase or uppercase.
Okay, so even without getting all fancy with regex, we can still do a lot to clean up our text data.
Yep. And as you get more comfortable with Python, you can start exploring those more advanced techniques.
I like that approach. Start simple and work your way up. But before we finish this part, I have one more thought. We've talked a lot about like fixing problematic data, but the real key seems to be understanding why it's problematic in the first place, right? Like, how do we go beyond just fixing the data and actually learn from it?
That is an excellent point, and it's something we're going to dive into in the final part of our deep dive.
So we've been talking about how important it is to really understand our data, right? Not just trying to like fix it, but actually figuring out what it's telling us.
Exactly. It's kind of like shifting from data cleaning to data understanding, you know? Instead of just how do we fix this, it's more like what is this data trying to tell us?
I like that data understanding. Makes it sound a lot more interesting. But can you give me some like concrete examples how this data understanding actually works? Like how can it lead to real insights?
Sure. Let's go back to that streaming service example, right? Lots of NaNs in the watch time data for a new show. What could be going on there?
Well, maybe people just aren't liking the show. Or maybe the pacing's off or something.
Right. But it could also be technical stuff. Like maybe there are playback problems on certain devices, or maybe it's not even available in some regions.
So like the same symptom missing data could have a bunch of different causes. How do we know which one's the right one?
That's where the detective work comes in. You got to gather more evidence. Like the streaming service could look at user feedback or check the system logs for errors or even do, like A/B testing with different versions of the show.
Oh, that's a good idea. So it's all about like connecting the data to the bigger picture, right? Looking for patterns and stuff that can help us make better decisions.
Exactly. And it's not just for streaming services. Think about like a retail company, right? They're looking at their sales data and they see tons of NaNs in the customer feedback section for a specific product.
What could that mean?
Well, maybe the customers just aren't finding it easy to leave feedback. Like maybe the form's too long or they don't know where to go to leave it.
So it's not that they don't have feedback, it's that they can't give it.
Right. And if the company just ignores those NaNs, they're missing out on valuable information that could help them improve their products and make their customers happier.
Wow, these examples are really making me think differently about data.
Mm-hmm.
It's not just about numbers and algorithms, it's like a window into how people behave and how things work in the real world.
Exactly. Data tells a story, and our job is to listen to that story and figure out what it means.
Well said. I think this has been a really great deep dive. We've learned so much about NaNs and about data in general. Any final thoughts for our listeners?
Yeah, I'd just say approach data with curiosity. Don't be afraid to ask questions and dig deeper. And don't just assume you know what the data's telling you. You got to be a little bit of a detective.
Great advice. Thank you so much for sharing your expertise with us today. And to our listeners, thank you for joining us on this data adventure. We hope you've enjoyed it and learned some new things. Be sure to check out the show notes for all the resources we talked about. Until next time.
Happy data exploring.